There are a lot of problems you can solve using the optimization of a quadratic function, and I'll show you two of them in this video. One is with a piece of wire. It measures 16 centimeters. The wire is cut into two pieces, and each piece is bent into a square, and we'll let x be the length of one side of just one of the squares. So the whole thing is 16, and we're taking a square, which is x by x. All of them are x. And then we have another square, not necessarily the same size, but I'll name this one y. One of the lengths of the sides as y. And if we would take this and bend it all back, so like they're kind of bending it into two pieces. We do have a wire cutter, but I'll make the gap a little bigger there. We're bending it, and we have that 4x from this 4x plus 4y. That total length equals 16 centimeters. So we can also write this, if we divide the whole thing by 4, this is x plus y equals 4. Okay, so now find a function that gives the total area ax enclosed by the two squares in terms of just x. So if we're looking at the area, and I won't put it in terms of x right away, but the area would be x squared plus y squared. X squared is from this area here, and y squared is this area here. And we're trying to get this in terms of just x. And so we will substitute using this equation here. I'll say y equals 4 minus x, and I'll substitute y into there. This will give me a function of x, ax equals x squared plus 4 minus x, the whole thing squared. And I'm going to simplify this, so x squared plus 16 minus 8x plus x squared. This now gives me x squared, or 2x squared, minus 8x plus 16. And this will be our function of the area. Right, now it says find the length of x that minimizes the total area of both the squares. Okay, so we want to find the vertex, and this is a quadratic, so we're looking, this is quadratic, so we're looking at the opposite of b, so 8 all over 2 times a, which is 2. So this is 8 over 4, which gives me a value of 2, x equals 2. So the length x that minimizes the total area is 2, or 2 centimeters. We make this one a 2 by 2. And it looks like, actually, from this equation here, y is going to be a 2 by 2 as well. So what's the minimum area enclosed by both the squares? We can either just think about what's happening with both of them. They're both 2 by 2s. That's 4 by 4, but it gives us 8. Or we could just plug this into the equation. So we get 2 times 2 squared minus 8 times 2 plus 16. And this is 2 times 4 minus 16 plus 16, which gives us, those cancel, that gives us just 8. So 8 centimeters squared. Okay, so now moving on to the next one. It says Judy has 120 meters of fencing. She will use the fencing to form 3 sides of a rectangular garden. The 4th side will be along a river and will not need fencing. Okay, so let me draw a quick picture of this. This is going to be my river. Lovely blue river there. And we have 3 sides of a rectangular fence. And I'll say this side is X, that side is X, and this side is something else. We're not sure exactly what it is right now. But from this, we can add all 3 of them together. So we get 2x plus y equals 120 meters of fencing. That total perimeter is 120. And the area is x times y. But I can take this equation and solve for y. I get 120 minus 2x. And I'll substitute y into there. So a now of x, since it's going to be a one variable, equals x times 120 minus 2x. This is 120x minus 2x squared. And this is the same as negative 2x squared plus 120x. Just writing it a different way, different order. Okay, now it's saying what dimensions would I use to maximize the area. I can maximize this quadratic by looking at its vertex. So the opposite of b, which is 120, divided by 2 times a. This is giving me negative 120 divided by negative 4. And this gives me 30 meters for x. So 30 meters. We also want to get the y value. So y equals 120 minus 2 times 30, which is 120 minus 60, which gives me 60 meters for the y dimension. So it's 30 meters by 60 meters. Those are the dimensions. And what's the maximum area the garden can have? We just take those two and multiply by each other. So 30 times 60 gives me 1,800 meters squared.